right, today we're going to do 714. We're going to do direct variation. Now, direct variation has an equation, as you can see down here at the bottom. And the thing we need to realize is that we have a y and an x, and that k value that's circled is going to be a constant. It's not going to be a variable, it's going to be a number. Okay, I'm going to write down some other equations that are direct variation equations. This first one at the bottom down here has a pi value along with our pi value here, and our 4 value here, which is our constants for each of those equations. Now, let's look at this top one. We have a p equals 4s, and if we were to put this into a table of values, and if I have my s here and my p here, if I put a value in for s, like 1, that turns into a 1. I multiply by 4, I'll get a 4 for p. If then we put a 2 in for s, we go larger with our s value. We'll have 2, which is the s value. A 4, that will turn into an 8 for our p value. I want you to notice that as the s values go up, so are the p values. That's what a direct variation does. As we increase one variable, we increase the other. This is going to happen with all of these. If I plug a value in for d, I'm going to multiply it by pi, which is going to increase that value, and we'll get our circumference, or c. If I put a value in for r and r squared, then I multiply by the pi, the area will also go up. So these are all direct variation. Okay, we have our equation y equals kx. We call the x variable our independent variable, and we call the y value our dependent variable. If you notice when I put values into the chart a little bit ago, the independent variable goes on the left, and the dependent goes on, let me say that again. The independent variable goes on the left, and the dependent goes on the right. And I normally put values into the independent variable, like I put a 1 and a 2, and I multiply by that constant to see what I get out, because this y value depends on the x value. Okay, let's do a problem. If y varies directly as x, and y is 18 when x is 4, what is y when x is 6? And I'm going to rewrite the equation here. Okay, that's the general one that we always write. Y equals kx. We always write it if it's a direct variation, and it says the problem says it's a direct variation. And so I wrote the 18 right under the y because it says that y is 18. And then it says here that x is 4. So we're going to put a 4 right underneath that x. We're going to be looking for k. So we're going to solve that for k. And so I've got to find that k so that I can plug it right back in here, because it says that x is 6. So I've made that x be 6. So I'll solve for that k by dividing both sides by 4, and I'll reduce the fraction to 9 over 2, which makes 4.5. So in the place of that k, I'm going to put the 4.5. And now all I have to do is get my calculator out and multiply the 4.5 times the 6, and I got 27. And so that will be the y value when x is 6. Okay, let's do another problem, and let's read it. It says that the distance an object falls varies directly as the square of the time. If the object falls 144 feet in 3 seconds. How far will it fall in 5 seconds? So we have to determine our equation. We've got to find our equation. And so it says the distance varies directly as the square of the time. So we're going to have a d equals, then we have to have our k, but our time will be a time squared. In the place of the d, we're going to put our 144. In the place of the time, we're going to put a 3, but the 3 is going to be squared. And 3 squared is 9. We'll bring down our k and our 144. We're going to divide both sides by 9. 144 divided by 9 is equal to 16. So now our job is to place the 16 in the place of the k that is right here. Now, it says the end here that we're going to say how far does it fall in 5 seconds. So the how far is the d, and the time is the 5 seconds. So we're going to place the 5 in the place of the t. We're going to multiply that 16 and the 5 squared together and get 400. We can't forget to write our feet. And we're done. It's important to always remember that our direct variation equation is y equals kx, where k is a constant. We are done.